Hi learners, welcome to this session. So today we are going to see about introduction to multi-threading. So it's an important concept. Here we are going to deal with multi-threading, which is nothing but implementing a concept known as multitasking. First of all, let me tell you what is multitasking. So multitasking is nothing but the activity of doing more than one task at the same time. So here we keep the processor engaged in such a way that more than one processes are using the CPU time efficiently. Let's get into the task. So this is the topic that we are going to discuss today, Introduction to Multi-Threading. First, let's see what's multitasking. It's a process of accepting or executing multiple tasks. As I said earlier, we are going to keep the CPU engaged, or we are going to make maximum utilization of the CPU time, which is very efficient, by assigning more than one tasks to be done at the same time. So this can be accomplished in two methods. The first one is by process-based multitasking, or we call it as multiprocessing. And the second one is by thread-based multitasking, which is also called as multi-threading. First one, process-based multitasking. So in multiprocessing, what we do is each process has an address in the memory. So each process is going to occupy a separate space in the memory. And this process will then do its task, and the next process, even though it is doing parallelly, it is going to occupy another set of space in the memory. And if we require the processor to switch from process 1 to process 2, we have to ensure that the next processor's memory gets loaded into the CPU. So here we mentioned that the process has its own utilization of the CPU, etc. So each process is called as a heavyweight process. The next concept of implementation of multitasking is multi-threading. So threads share the same address space. So here each thread is referred to a process, and we say that each thread is going to share a common address space. So when we are sharing a common address space, it is understood that we are not taking different slots of the memory. In turn, the threads will be taking their turn in the memory. So a thread here becomes a lightweight process, and the cost of communication between the thread is low because they occupy the same space. In the buffer, they can store their content, and another thread can fetch the content. So inter-thread communication becomes much more easier. So we are going to see in depth about multi-threading and how to implement it in Java. Let me introduce you again in depth about the concept of multi-threading. So a thread is the smallest processing unit, or we call it as a light subprocess. By the term light subprocess, we mean that it's not going to occupy a huge amount of memory. So the process of running many threads concurrently in Java is known as multi-threading. So to accomplish multitasking, we are going to use this method called as multi-threading. So what we are doing is we are assigning multiple threads, and these threads we are starting their execution parallelly. So thread 1 will not interfere with the process or activity of thread 2, and thread 2 will not affect the processing of thread 3, and so on. Let's see some characteristics of threads. So a thread is a lightweight subprocess. As I earlier mentioned, it is a part of a complete process, or we can say that if the whole activity is introduced as a task, then subtasks are called as threads. So it's like an individual task to be done. So it is a separate, it takes its separate path of execution, and they are independent. We call it independent because they need not rely on another thread. So it is broken down into such small parts of jobs. So threads are independent, and if they occur, if there is an exception in any of the cause, it does not affect the other threads. because the thread processing itself, we are trying to put them inside a try or catch block. And in case there is an exception that arises, it does not affect the processing of the remaining part of the program. Here, the main advantage is the shared memory area. So because the threads utilize the shared memory space, we prefer using thread processing instead of multiprocessing. The same concept that we have seen earlier. So to conserve memory and the switching between threads, that is context switching or inter-thread communication is much efficient because of this common memory space. We can go in for multi-threading preferred more than multiprocessing. We are going to see certain advantages of multi-threading. First one, it doesn't block the user because threads are independent. So when one thread and another thread can do their task parallelly, there is no need for one thread to block another thread. So you can perform multiple operations at the same time. This is the first advantage of multi-threading. Second one, we can perform many operations together, so it saves our time. Third one, threads are independent. As we saw earlier, they share a common space. But since the task is split down to the bottommost level, the processing of one thread does not affect another thread. So if an exception arises in a single thread, it does not affect the processing of the remaining threads. So this is again an advantage here. So next one is the implementation of Java thread. So let's see how to implement Java threading. So Java provides the thread class to achieve threaded programming. So thread class provides a constructors and methods to create and perform these operations. There are two ways in which we implement multi-threading. The first one, using the object class, and we extend the thread class. The second one is we implement the runnable interface, and again, we can create a thread and do our processing. So the next concept that we are going to discuss is about the life cycle of a thread. So how we start a thread, how it gets processed, and then finally, how we terminate a thread. So in Java, there exists a thread can be in any one of the following states. The first state is new state, the second one active, the third one blocked or waiting, the next one timed waiting or terminated. So let me go to the flow of these states. So first we have the new state. So this is a state where a thread gets created. So at the state new, we create a new thread. So the next state is when we call the run function. So when we call the run function, the newly created thread enters the running state. So running state also means that the thread is active. It has either received the CPU or it is waiting for the CPU. Now, from this state, the thread can be moved to three other states. The first one is blocked, the second one is waiting, the third one is timed waiting. We'll see what these are. The first one is in case a high priority thread comes into execution. Now what happens? A thread which was already under execution will acquire a lock and it will move to block state. The second case, if a thread requires any of the resource, so from the running state, it will move to wait state. So at wait state, there is no time mentioned when the thread is going to get back into execution. The last part or the last state is timed waiting. A thread from this running state, it will move to the timed waiting state in a case that, again, it's waiting for a resource or it has been interrupted by a high priority thread. But the difference between waiting and timed waiting is nothing but, in timed waiting, we know how long the thread has to wait for the processing to stop. Okay, so after this time duration is over, the thread will automatically get back into the running state. Finally, if the thread completes its execution, it's going to the terminated state, and which also means that the thread has completed its task and it's going to exit. Now let's see about these states again in detail. So the first one, new state. So new state means that we have created a thread and this thread is ready for execution. So one task to be done is assigned along with this thread. Second one, active state. So when we invoke the start method, a thread which has just now been created moves to the run state. So the active state contains two states within it. The first one is runnable and the other one is run. The next state is blocked or waiting. Now, when we say a thread is blocked, it means a thread is suspended. So a thread is suspended means it is temporarily inactive, or it moves to the state where it can be removed or it can have to wait for endlessly until the user brings it back into execution. The next is wait state. Again, if a thread requires a resource, it may be put to wait. Or if a high priority thread gets into execution, it may push a low priority thread into wait. The next is timed waiting. When we say timed waiting, the essence why we get into timed waiting is, in the previous case, wait state, a thread is pushed into this wait state. It may endlessly wait for a resource, and this may lead into starvation. Starvation in turn will get us into deadlock. So timed waiting ensures that this starvation does not occur. Okay, it ensures that the thread lies in the waiting state only for a specific span of time. So after this time gets over, the thread gets back into the normal processing. For example, let's see that with an example. If a thread named A has entered the critical section, let's assume that this is the critical section. So if a thread A has entered this critical section, and it is not willing to leave this critical section until all the resources are achieved, and another thread named B is trying to access this critical section, there may be possibility of getting into endless wait. So what we are doing here is, to avoid endless wait, we are putting this thread B into sleep. So we are going to use a method called sleep, and we will be assigning that thread B has to wait for 200 milliseconds or 400 milliseconds. So in this case, what happens? The thread will wait for this particular period of time, and after the time gets over, the thread will again try to get into the critical section. You got this, I think. So next state is terminated. A thread reaches this termination state because of the following reasons. So when a thread has finished its job, it either terminates normally or the user terminates the thread. The next case is abnormal termination. It occurs when, due to unusual events or the arise of an exception, we may terminate a particular thread. So a terminated thread means that the thread is no more in the system, and in other words, the thread is dead. So we can also kill a thread, but once a thread is killed, it cannot be called again in the processing. We have seen the flow of states, so we'll move forward. Next station of threads. So in Java, one can get the current thread using the thread.getState method. So the getState method will tell the user in what state the thread is currently in. So the first case, if a thread is in new state, it means we have just created the state thread. That means the thread is new. It has now been created. It is not got into execution. Now, if a thread is in runnable state, it means the thread is waiting in the queue to run. If we get the state as blocked, it means the thread is waiting to acquire a lock. The thread, if we get the current status as waiting, it means either the wait method has been invoked or the join method has been invoked. In any of these cases, the thread is waiting for another thread to complete its task so that it can continue its execution. The next state that we can reach at is timed waiting. So here the waiting has no time constraint as in the previous waiting state. Here in timed waiting, we have a limit or a period for which the thread is mentioned to sleep or to wait. So once this time gets out, that's if we reach the timeout period, the thread will automatically get into the run state. If we get the thread state as terminated, it means that the thread is at its completion of its execution. And once it reaches this period, the thread is going to quit. We have an example here to demonstrate the thread states. First one, we have a class called process. It implements the runnable interface. As I said, we can go for two ways in which we implement the multi-threading. So here we are implementing using runnable interface. We are using ID and burst time, two variables. Now we have a constructor called process in which I'm assigning ID and burst time to the variables ID and burst time just to get the current values. Next, I call upon the run function. So here within the run, we are going to mention how the thread gets started. So for each seconds, the thread must get started. Everything is mentioned here. The time unit, seconds, and as the burst time is given as the sleep. So once the burst time maximum value is reached, the thread will be put to sleep. So in the catch, I'm getting if any interruption is there, if any interrupt arises, I'm handling it using this catch block. Finally, I'm printing the process, its ID, and the completed state. Now in the main function, I'm creating an object called processes. And with this object, I'm passing the values. Here, first I have the IDs of the process and then the burst time. So once the process reaches this burst time, it will automatically quit and the next process will get into execution. So here we are mentioning that we are going to create a thread to represent each process. And finally, we are starting the threads. Let me show you the execution of this. So here I'm using an online compiler called Programmers. So using this compiler, I've just pasted my code here. We are going to see the execution. We are having totally 5 processes, process 1, process 2, process 3, process 4, and process 5. So the burst time for process 1 is 2 milliseconds. For process 2, it is 4. For process 3, it's 1. For process 4, it is 3. And process 5, it is 5. So when we run the code, so once the burst time of each process gets over, it automatically transfers to the next process. Thank you. So we will continue the presentation. So the next concept that we are seeing is threads in multi-threading, or the methods that we use in multi-threading. So next we are continuing with the methods that we are going to use in multi-threading. So first is the start method. As I said, when a thread is created, we call upon the start method. So the start method says that we have a new thread that is created. Next, we have the run method. So to do an action for a thread, Or to move the thread into the runnable state, we can use this run method. Now, to move a thread to a timed wait period of time, maybe for 20 seconds or for 3 milliseconds or 300 milliseconds, we can put a thread to sleep or wait. So using the sleep method, we are going to temporarily halt a thread. So once the timer is over, the thread will get back into execution and will move to the active state. So the next is current method. So current thread. So using this current thread method, we are going to identify in what state the thread is. So next is join method. So it waits for the thread to die. That means the thread will move into either blocked state or in wait state. Next, get ID. So it returns the ID of a particular thread. Is alive method. It tests if a thread is active or not. Then we have the stop method. It is used to halt a thread. Destroy method. It is used to destroy the thread group, which means we are going to remove the thread group. And in turn, if a thread has subthreads or groups, all these groups together will be removed. We have the resume method, which is used to resume a suspended thread, a thread that is put into blocked state or wait state or timed wait state can be brought back into active by using the resume method. Now we have the suspend method using which we can block a thread. Next, we have the active count. So it returns the number of active threads in the current threads group. So thank you for this wonderful session. Thank you for listening to the session. So in today's session, we have discussed about the various types of threads, how to create threads, how the threads are processing or moving from one state to another state and so on. I hope it has been a helpful session for you. Thank you for your patient listening.